won't have a lesson. What are you talking about? From Monday? It's not up? What video? I have no idea even. I'll look. I'll try to find it. Sorry. All right. I'll look. I'll try to spend some time this next hour and look through that stuff. So, yep. I'm just getting behind this time of year. Okay, here we go. We got to change the problem a little bit. It's going to do east, and wind's blowing at north 20 degrees east. Okay, so here's our problem. We're going to pick up with our vector work with a word problem. We're going to get another stuff. Pilot's headed due east. Plane at a speed of 450 miles per hour relative to the air. Wind's blowing at north 20 degrees east at a speed of 60 miles an hour. So we want to be able to find the velocity in component form, the jet velocity in component form, the true velocity, and then the true speed. So here's what the problem's trying to get at. Yep, sounds very challenging. But you're going to have to know this problem for your assignment, and you're going to have to know it for your study guide, and you're going to have to know it for your test. I promise you. Okay? So can't be more transparent than that. So here's what's happening. Question. 500. I don't know. 6. Okay, so here we go. I am at an airport, okay? I'm waving goodbye to my family. I'm walking at 2 miles per hour. All of a sudden, I step on one of those horizontal escalators. That quickly takes me from one end of the airport to the other, and it is traveling at 5 miles per hour. And I am also walking on it at a rate of 2 miles per hour. So you tell me, what is my speed with respect to or relative to my family? 7, because I have my speed and then the speed of the escalator. What is my speed relative to the escalator? 2 miles per hour. So you can understand that it depends on what your speed is relative to. And so in this situation, the plane is flying as a speed of 450 relative to the air, but the air is also blowing. The wind is pushing through, okay? So as the plane is flying in this direction, the wind is blowing in this direction. It's mostly a crosswind, but it's a little bit of a tailwind, and this is really impacting the flight of the plane overall. So what we're going to do is we're going to express the velocity of the wind in vector component form. So I'm going to draw my first quadrant because everything's headed to the north and the east. And I'm going to draw a vector to represent the wind. 60. Why? Because speed is the absolute value of velocity, or the magnitude of the vector. Okay? So what I want to do is I want to find, given an angle, I want to find the horizontal component, and I want to find the vertical component of that vector. So, anybody know what angle is formed? Okay, a right angle between the horizontal and vertical side, but what about the angle at the bottom? 70. Yes, it would be 70 degrees. Because it's north 20 degrees to the east, so therefore there's 70 degrees left over. Okay? You see that? All right, so I need to come up with component form. If you recall from the other day, we said that AB can be written in component form, where A is equal to the magnitude of velocity times the cosine of theta, and B is equal to the magnitude of the vector times the sine of theta. Do you remember this a little bit? Bring it back to you. So we do the magnitude of the vector. What's the magnitude of the vector? 60 times the cosine of 70, and 60 times the sine of 70. Please, somebody on your calculator, compute 60 cosine of 70, and somebody else compute 60 sine of 70 so we can move quickly as we just had our tornado drill. 60 cosine of 70, what do you got? Well, you guys really want a lesson tomorrow, don't you? What do I got? 20.5. What is 60 sine of 70? 56.3. Okay, now if you can't see that, that ends up being this coordinate. It's 20.5 horizontally and 56.3 0.3 vertically. That's what we just calculated, okay? But that's the vector in component form. What we're going to do now is we're going to express the velocity of the jet relative to air as a vector in component form. Well, what is the speed of the jet? 450. This one is easy to calculate. What's the angle formed? 0. So you have 450 times the cosine of 0 and 450 times the sine of 0. What's the cosine of 0? 1. So 450 times 1 will just be 450. And what's the sine of 0? So you get 0 there. As you can see, obviously, this coordinate would be 450, 0. Didn't really even need to do any work. So you have those laid out. So finding the component form really isn't that much work. Now the question is, find the true velocity. Well, the true velocity is going to be when we add those two together. So in my representation I gave to you guys, this is where we step onto the escalator and both are working together now. Okay? So because there's a little bit of a tailwind, it should be more than 450 miles an hour. And so what we want to do is we want to find the sum of the vectors to find out that new location. Well, all we have to do is take 20.5, 56.3, and add that to 450, 0. What do I get? So this is the true velocity in component form. That's it. So I know, well, this often is a question people they're just like, forget it. I can't even get started. We've already done component form before. We just have to recognize the terms of the problem and then just add them together. And then the true speed, well, speed is equal to the absolute value of velocity or the magnitude of the vector. How do you find the magnitude of a vector? So let's do it. What's the square root of 470.5 squared plus 56.3 squared? Yep. I don't remember the decimal. 473 point what? 85. Great. So that's miles per hour. All right? It also says find the direction of the jet. So in other words, I want to know what that angle is right there. Very good. Tangent of theta is equal to b over a. B in this problem is 56.3, and a is 470.5. So let's inverse that and see what we come up with. Somebody theta? 6.8 degrees. Is that what you got? Okay, so this angle is 6.8. So let's describe the direction as in directional bearing format. So we've got, it's traveling to the northeast. How many degrees to the east of north? 83.2. An 83.2 degree turn. Yes? Okay. All good? Are you angry about anything? All right. Flip it over. I'm going to move pretty quickly through here because this is pretty easy stuff for you. Dot product. So the last thing we need to learn about is how to multiply vectors. We show you how to add them, but if you have a vector v is equal to ab and vector u is equal to cd, then the product of the two vectors u times v is equal to You take the x values, you multiply them together, and you add it to the y values multiplied together. That is called the dot product. That's how we multiply them together. So you will not, when you take two vectors, you multiply, you don't get another vector. You actually get a numerical result. So we're going to do that. Let's try doing the product of two vectors. We're going to do u times v right here, and then later on we'll show you the angle. Okay, so I have -1 times what? Is it this 2 or that 2? It's that 2 plus what? So I get -2 plus 6 is 4. And the reason why I said this 2 and that 2 is because some people made that mistake on the test. They thought you just multiply the x values together and multiply. I'm sorry, they thought you multiply both parts of u and the both parts of v. That's incorrect. Okay, you got to do the x values for each and the y values for each and add them together. Okay, this one it's written in IJ form, so you have 1, -1, and you have 3, 4. So if I multiply a times b, what do I get? I get 3 minus 4 is -1. So you can see that the product of the two vectors can be positive. It can also be negative. That leads us to the angle form between two vectors. Suppose that you have a vector that looks like this and another one that looks like that. You want to find the angle form between them. Can somebody tell me what is the smallest angle that can be formed between two vectors? Think about it. 0. What's the largest angle that could be formed between two vectors? I suppose you could make that argument, but I would say no. 180, right? You end up finding the smaller of the two angles. If you want to make an argument that you could go greater 180, I suppose that could be the case, but we'll say it's between 0 and 180. There is one of the trigonometric functions, sine, cosine, or tangent, that is friendly to values between 0 and 180, and that is cosine. So the cosine of an angle, and I will not prove this for you because we don't have time, but cosine of theta is equal to the dot product, u times v, divided by the magnitude of u times the magnitude of v. And yes, these are formulas you'd like to put on your sheet. Okay, I'm not doing it for you. This is something you need to take care of. So let's set up the formula for the angle. I've got cosine of theta is equal to, and it starts by the dot product. Do we already know the dot product here? What is it? 4 divided by, what's the magnitude of u? Square root of 5. What's the magnitude of v? Square root of 13. Or 4 over the root of 65, right? I did a squared plus b squared square root. So I take out my calculator. I punch it in correctly. I do cosine inverse of 4 divided by the root of 65. Close my parentheses off. I get 60.26 degrees. That is a skill you're going to have to be able to perform on your test, and you have practice in your assignment today. We set up the next one. Cosine of theta is equal to what? -1. That's the dot product divided by, what's the magnitude of 1, -1? Root of 2. What's the magnitude of 3, 4? Square root of 25, which is 5. So we have cosine of theta is equal to -1 over 5 roots of 2. So cosine is negative. Where is cosine negative? Second quadrant. So what kind of angle is this going to be? Acute or obtuse? Obtuse. Let's see if that works out. Cosine inverse of -1 divided by 5. Whoop, I have to put parentheses. That's the mistake you'll make on the test. You won't put parentheses, you'll get a different angle. I get 98.13 degrees. Remember your parentheses in that situation. Okay. Not too bad, huh? So that brings us to orthogonal vectors. Orthogonal vectors are perpendicular. If two vectors are perpendicular, what is the angle form between them? 90 degrees. Well, that means that cosine, let's see, where's cosine of 90? 0. So that means that this expression up here would be equal to 0. If something is something equal to 0 if the top is 0 or if the bottom is 0? The top. So we know that angles are orthogonal if the top is equal to 0, or if the dot product is equal to 0, then two vectors are orthogonal or perpendicular. Very straightforward. So what we want to do in examples, in these two examples here, is determine whether the vectors are orthogonal. So we're just simply going to do the dot product. If we get 0, they're orthogonal. If we don't get 0, then they're not orthogonal. So A times B is -2 plus 2, which is 0. These are orthogonal. Next one, A times B so are they orthogonal? If anybody came up with 0, I put it like that to see if I could confuse you, get you come up with 0, you know, in case you came up with a positive instead of negative. So, all right, so be careful. Just because it looks like they're going to cancel, they may not. Okay, flip it over. It's our last page. So let's apply our work. A 4,000-pound truck is parked on a driveway. This box is going to represent the truck. That's inclined at 30 degrees to the horizontal. It says find the magnitude of the force required to prevent the car from falling down the driveway, and find the magnitude of the force experienced by the driveway due to the weight of the car. This is not a problem that's going to come to you easily. You're going to have to really just trust the way that we set this up and try to think about the physics of the situation. Some of you maybe have physics, maybe you've seen this type of problem before, but 4,000 pounds is, you know, really measured by what gravity is doing to us on this earth, right? Okay, so this weight is directly down, meaning it is perpendicular to the horizontal of the earth, and its force is 4,000. That's what's being exerted right now on the earth. Okay. However, this blue line represents the force against the driveway. And this red dimension represents the holding force. So you can see that that 4,000 is a force, and it's being delivered at an angle, and that there's a horizontal component and a vertical component to it. The horizontal component being in red, the vertical component being in blue. Okay? Can anybody tell me what this angle is right here? 60 degrees. So you have 30, 90, that would make that angle 60. Now, let's think about the problem just a little bit so you can understand what's going on. If I have a truck weighing 4,000 pounds sitting in front of me right now, how much force do I have to press against it to keep it from rolling back on me? None. It's sitting on a flat surface with no incline. It's just going to sit here, right? Now, suppose I have a truck that's sitting on a vertical incline above me. It weighs 4,000 pounds. How much force do I have to exert to keep it from falling on me? 4,000. So you can see that at 0 degrees, it would be 0, and at 90, it would be 4,000, right? So we're at 30 degrees, so there's going to be some weight in between there. That's going to be calculated by this red component right here. Okay, the driveway. Think about the driveway. Okay, this floor right here. If I had a car sitting on this floor right here that weighed 4,000 pounds, then the 4 would feel like it was holding up how many pounds? 4,000. If I had a vertical driveway that the truck was sitting on, how many pounds would the driveway be feeling? 0, right? Okay, yeah. So you can see those situations developing. So let's work through it. This is simply just a horizontal and vertical component piece. So in A, we have the horizontal component, and in B, we have the vertical component, okay? So how do I calculate the horizontal component? This is what we've been doing all along. Cosine of theta times the magnitude. 4,000 times the cosine of 60 degrees. Anybody know what cosine of 60 is? 1/2. So 4,000 times 1/2 is 2,000 pounds of force. Now it says find the magnitude of the force experienced by the driveway. Well, that's the blue line. That's perpendicular to the driveway. That's how much weight the driveway is feeling. Okay? Well, I take 4,000 times the sine of 60. Somebody? Yep, 2,000 root of 3, which is, give me a decimal, 3,000. And that's what the driveway is feeling. Okay. Okay, what did you get? Okay, maybe you just typed it in incorrectly. There you go. All right. Or I wrote it off wrong. All right, our last piece that we have to work through is work. When we apply this all together, we get work is equal to force times distance, or displacement. And both can be written as vectors. And so it's the dot product of these two vectors. We'll try a basic example and then a word problem. It says find the work done by the force F in moving an object from P to Q. So for example, okay, I'm applying a force to this wall right now. What is how many feet have I moved this wall? So how much work have I done? I haven't done any. Okay? So in order to get work done, something has to be accomplished. It must move. So all I do is I take my force vector, which is what? 1, 1, and I multiply by a displacement vector. So the displacement is how far has it moved? So it's moved from P to Q. So how many units horizontally has it moved? How many units vertically has it moved? Multiply, what do we get? 3 plus 4 is 7. So 7 is the work being done. We try the next one. What is the force vector? 3, negative 2. Displacement vector. It's moved from 0 to negative 1, so negative 1 is the horizontal component, and it's moved from 3 to 2. Again, negative 1. I multiply, I get negative 3 plus 2. Some people are like, can negative work be done? Well, sure. Yeah. Rach, stand up. Who's doing positive work? Who's doing negative work? Okay. I'm being displaced negatively. He's being displaced positively. Okay. We're both applying force. The force that she's applying is greater. Okay. There you go. Way to go. You're super strong. Last problem. So let's calculate force for the lawn barbers. Okay. Got the lawn barbers ready to go. The lawn salon. I like it. Make it happen, guys. Go get a business. Pay taxes. I need them. I need you guys to pay taxes. I'll run out of Social Security when I'm retired if you don't. Social Security? You pay in. You pay in while you work. So then when you don't work, you get stuff back. That way you got money to go buy groceries. Go to a Twins game. All right. It says that it's being pushed with a constant force of 60 pounds. And we always assume that this is on the handle. Okay? Good luck today. What is the angle formed against the ground? 35 degrees. So we have a vertical component and we have a horizontal component. What is the total distance that it travels? 80. Now, you know that work is equal to force times distance. I need a distance vector or displacement vector. How many units is it displaced horizontally? How many units is it displaced vertically? I need a force vector. I know it's 60 pounds of force, but that has a horizontal component and a vertical component. How do I figure out the horizontal component? 60 cosine of 35. How do I figure out the vertical component? 60 sine of 35. What is 60 cosine of 35? And what is 60 sine of 35? So you multiply these together and you get your work that's done. Notice what happens with the 0. It cancels out the 34.41. So 49.15 times 80 is? Let's figure out a label. What is force measured in? Okay. In this problem, what is force measured in? Pounds. What is distance measured in? So it's feet, pounds. That's the label. Now, notice, you're applying 60 pounds of force. But it's only counting for how much? Your 60 pounds of force is divided up, isn't it? Into two pieces. So the 60 really only counts as 49.15, doesn't it? So you're better off to lower that handle. Some people are like 35 degrees. That's pretty low angle. The higher you move the handle on the lawnmower, well, I guess it really depends on the wheels and everything. But, you know, I'm just saying it, you know. Yeah. So, yeah. What if we had an incline? What if we had a 5-degree incline? Then would it be 80, 0? No, it might be like, say, 77 and 2 or something like that, okay? All right, you want an assignment. We're all done. You're going to get your homework cover sheet tomorrow. Here you go. You have tomorrow to work. You have Monday to work. You have this weekend to work. You don't have anything important going on this weekend. So the assignment looks lengthy. These two are word problems. The others are pretty quick. Go ahead. You taking my picture? All right, go be great. Do what's difficult.